Hi students, it's Mrs. Denton. Today we're going to look at how to classify triangles. Now this will most likely be a review for you, so I'm going to go a little bit faster than usual. Okay, first we're going to talk about the word acute and what that means when we're talking about a triangle. We know what an acute angle is. An acute angle is an angle that's less than 90 degrees. But with a triangle, we're talking about three angles. So an acute triangle is a triangle where all of the angles are less than 90 degrees. All angles of the triangle are less than 90 degrees. Okay, all angles of the triangle are less than 90 degrees. So draw yourself a little picture over here. It doesn't have to be perfect in any way, but all of our angles are less than 90 degrees. Okay, really important to remember that acute talks about the angles. An acute triangle is a way to describe the triangle based on the angles. All right, next we have an equilateral triangle. An equilateral triangle, let's look at the prefix here. Equa stands for equal, and then lateral is talking about the sides. So equal sides. An equilateral triangle is a triangle that has all equal length sides. All sides are congruent in length. All right, so over here, if I'm not perfect at drawing an equilateral triangle, there's a really easy way for me to show that these sides are equal in length, and that's to put our little congruent symbol on it. All sides are congruent. So equilateral is a way to describe the sides of a triangle. Sides of a triangle. Here, fun fact, jot this down. If you have an equilateral triangle and all the sides are congruent, that automatically means all the angles are congruent also. In fact, it means that all the angles are 60 degrees. If all the angles are congruent, then they're 60 degrees because, 60 plus 60 plus 60 is 180. So with an equilateral triangle, you know a lot of stuff. You know all the sides are congruent. Now you know all the angles are congruent, and that means all the angles are each 60 degrees. Okay. Next, we're going to talk about an isosceles triangle. Isosceles means that two of the sides are equal. Two of the sides are equal. Exactly two sides are congruent in length. Exactly two sides are congruent in length. So, real basic picture over here, just something to look at. Two sides. So I'm going to use my little congruent symbol on two of the sides. Two sides congruent in length. Now, since two of the sides are congruent, Since two of the sides are congruent in length, that also means we have two congruent angles over here. And those are going to be the angles that are opposite of the congruent sides. So this angle opposite this congruent side and this angle. So we've got two congruent angles, but that is a result of two congruent sides. So the word isosceles, this word describes the sides of the triangle. It's just kind of a side, or what am I trying to say? It is a side effect that these angles are congruent also. Two congruent angles. Okay, these are actually called base angles. Base angles. This angle up here at the top, this is called a vertex angle. You guys know geometry is full of vocabulary. So we've got our two congruent sides because of the isosceles part. That forces two angles to be congruent. Those angles are called base angles. And then that third angle is called the vertex angle. Okay, we've got a couple more vocabs here. Next we have obtuse. Okay, think back to angles. An obtuse angle is an angle that's greater than 90 degrees. But again, we're trying to describe the entire triangle. So I'm going to start with a picture over here. If I start with a really wide obtuse angle and connect it to form a triangle, there's no way I'm going to have more than one obtuse angle. This is the giant obtuse angle I'm talking about up here at the top of my picture. So I've got one obtuse angle and then two teeny tiny skinny acute angles. So in order to have an obtuse triangle, there's going to be exactly one obtuse angle. An obtuse triangle has exactly one obtuse angle. It can only have one obtuse angle. Therefore, the word obtuse, when we're talking about triangles, is describing the angle relationships. Okay. Well, this is really similar to a right triangle. Let's think about what a right angle is again. That's an angle that's 90 degrees, okay? So if you want to start with the picture, give yourself a right triangle. Remember, you'll know it's a right angle if it makes that 90 degree in the corner. If you can't draw a perfect 90 degree, put your box in the corner, and that's going to signify a 90 degree angle. So we have one 90 degree angle, and check out the other two angles. Again, those angles are acute. So a right triangle has exactly one right angle. Exactly one right angle. So when we say, look at this right triangle, again, that's a way to describe the angles. If I say, look at this right triangle, it doesn't tell me anything about the sides, but it does tell me there's one right angle. Now, something important about right triangles, it makes other vocabulary happen. The side that's across from the right angle has a special name. That's called the hypotenuse. You guys have known that. The two sides that meet at the right angle are called legs. So in a right triangle, the right angle part is what makes it a right triangle. But look at all this other vocabulary that shows up due to that one piece. Pretty interesting. Okay, the last piece here, the last vocab word is scalene. That's a funky word. Scalene means that there are no sides that are congruent. No congruent sides. Okay, so let's take a look at a scalene triangle. Do your best. Maybe I'll have a little short side, a longer side, and then a really long side. That's not my best triangle. But scalene means no congruent sides. No congruent sides. Guys, what happens, let's go back up here to the top. Let's look at equilateral. When we had 3 congruent sides, it forced all the angles to be congruent. When we had 2 congruent sides, it forced 2 of the angles to be congruent. So if we have no congruent sides, that means no angles are congruent. No congruent angles. Okay. The side lengths are related to the angle measures and vice versa. So here in our scalene triangle, we have no congruent sides. So scalene is a word that describes the side measures. So if you take a look at your list, okay, maybe I'll zoom out here. We've got 6 words that describe triangles. Good. There we go. 6 words that describe these triangles. Acute, equilateral, isosceles, right, obtuse and scalene. 3 of them describe side measure, and 3 of them describe angle measure. And I've tried to highlight that for you. Now you can have combinations of both. Like, let's take a moment and see if we can draw an obtuse isosceles triangle. That's a combo. That's one angle description and one side description. Okay, I think I'll just try and draw it right here in between them. So we have to have an obtuse angle, so a nice wide angle. But we also have to have 2 sides that are exactly the same in length. So here's my obtuse angle, and here's my 2 congruent sides. This would be an obtuse and isosceles triangle. We would need both words to describe it. We would need one word to describe the angle relationships and one word to describe the side relationships. Okay? Our little picture we've drawn here for the right angle, the right triangle, my picture anyway, it is a right triangle, but it's also scalene. Look at the side lengths. I've got one short, one medium, one long. So none of my sides are congruent, so therefore this would also be scalene. I would call this a scalene right triangle. Okay. So we have 6 words to describe our pictures, our triangles, but know that those 6 words can be combined together to give a very detailed description. Okay, flip over. Let's see what's next. Okay, now we're going to move on to the measurements inside the triangle. We've talked about this before in our do now practices, but let's make it more formal. Let's really talk about how many degrees there are within the 3 angles of a triangle. There's a fancy title called the triangle sum theorem that tells us that the 3 angles of a triangle sum to 180 degrees. The 3 angle measures of a triangle sum to 180 degrees. Okay, so what that means is no matter whether the triangle is a right triangle or an obtuse triangle or an acute triangle or scalene, no matter what the type of triangle, no matter the size or shape, all 3 angles will always add up to 180 degrees. So I've got a couple of examples to run through here with you, and you can see we'll start with something very basic, and we're going to work our way to something more detailed with algebra in it. And we're going to be relying on a lot of our skills from previous lessons, okay? So let's take a look at number 1. Here we've just got an isolated triangle. We don't know this angle shape. It looks like it's going to be acute. In fact, I know it's going to be acute because the obtuse angle has already been used. Now, if I have 180 degrees total to use inside the triangle, and I've already used 135 for this obtuse angle, and I've already used 20 for the acute angle on the bottom, I can subtract those 2 values from 180, and whatever is left over is going to be for my upper angle. Now, I've got a calculator over here to the side, so I make sure I don't mess up on my arithmetic. And I do 180, subtract these 2 values, and I've got 25 degrees left for this upper angle. Now that means all 3 angles added together sum to 180 degrees. That's about as basic as it can get. Okay, so next we have an example number 2. We have another triangle here, but I hope you notice there's more going on. We've got some intersecting lines that form vertical angles. We've got a line that's been split that forms a linear pair. So here's the looping topics. Vertical angles. They're not going anywhere. They're going to show up all year. And linear pairs. So I'm trying to figure out this obtuse angle on the left side of the picture, but I've got nothing connected to it. as the linear pair. So I can't start here. I'm going to use what I know about vertical angles first. I know that vertical angles are congruent. So if I have an 82-degree angle here on the top, that can transfer into my picture in the triangle, 82 degrees. And the same thing here on the right side. If I have 27 degrees, then it will be congruent to its vertical angle. So now I know 2 out of 3 angles of this triangle. So if I'm working just inside this triangle, I can use the triangle sum theorem because 180 degrees total, take away the 82 and the 27 that have already been used in these 2 angles is going to give me this third angle. 180 take away 82 and take away 27 leaves me with 71. Now that's the triangle sum theorem. The 3 angles inside the triangle have to add up to 180 degrees. So I use my vertical angles to find these 2 missing angles. I use the triangle sum theorem to find this third missing angle. But in the end, I'm looking for the linear pair. I'm going to highlight that. Here I'm using what I know about linear pairs to find this outside angle here. Well, I know linear pairs have to add up to 180 degrees. They're supplementary. Okay, jot that down if you forgot. This linear pair is supplementary right here. So I'm going to do one more subtraction. 180 degrees, take away that 71 degree angle is going to give me the supplementary pair. That leaves me with 109 for my final answer. Look, guys, these things we've learned in the past, they're not going anywhere. They're going to follow us all the way through. They're foundational pieces of geometry. So try not to lose hold of those things as we add more in. Example 3 is another long puzzle kind of problem, much like number 2. We have to start with what we know to kind of wiggle our way through to our final answer. Okay? So I'm going to start first with the triangle on the left. This triangle is only missing one angle. So I'll start with the triangle sum theorem that says all angles of a triangle add up to 180 degrees. So 180 degrees, take away the 25, take away the 85, leaves me with 70 degrees for the third angle here. Now somehow I have to transition from here into the triangle I'm working on. Okay, so there's actually another linear pair here. If we take this line and we split it using the triangle, then we have a linear pair. The 2 angles are this giant obtuse angle in red and then the smaller angle here on the inside of the triangle. Okay, so 70 and 69 added together make this 139 degree obtuse angle. Well, remember guys, linear pairs are supplementary. They're supplementary. So 180 degrees, take away that 139, that giant obtuse angle, leaves me with 41 degrees on the inside of this triangle. I'm just kind of working my way from left to right here using the triangle sum theorem, using linear pairs. So now I'm inside the triangle on the right, and it is a right triangle. This box here in the corner tells me that this is a 90-degree angle. So I'm going back to the triangle sum theorem. Here it is again. There's 180 degrees total. We've got a 90-degree angle here. Now we know this left side angle is 41 degrees. If we subtract those from 180 degrees, the leftover will be our final angle at 49 degrees. So these problems are rather challenging and there's not even algebra involved, okay? Here we're just looking at the relationships of the triangle sum theorem as well as vertical angles and linear pairs. Just something to keep in mind. I'm going to put that in a little bubble so that it stays in your brain, okay? Okay, for example 4 and 5, you see some algebra there. I hope that doesn't scare you. Let's see what that looks like. Here, the directions say solve for x. On number 4, we're starting out pretty simply. Solve for x, and there's no vertical angles and no linear pairs. In fact, the only thing I know is that all 3 angles of this triangle have to add up to 180 degrees. So this is the equation I'm going to use. Angle number 1, x plus 70, plus angle number 2, 78, plus angle number 3, 41, has to add up to 180 degrees. Well, first things first, let me combine like terms. 70 plus 78 plus 41 is 189. 70 plus 78 plus 41 is 189. So to solve for x, I can subtract 189 from both sides. And x equals -9. Now, if you're concerned about that being negative, plug it back in. -9 plus 70 is 61. This is a 61-degree angle. Is 61 plus 78 plus 41 180 degrees? 61 plus 78 plus 41. Checking it over here on my calculator. Absolutely. Remember, the angle measure is what must equal 180 degrees, the sum of the 3 angles. Okay. Number 5 is our final example here. It's going to merge all types of things together. Right away, my eye is drawn to this vertical angle. I also see a linear pair. I also see some algebra involved, so I know there's going to be several things to look at. First step I'm going to take is using the vertical angle. That one's so easy. 62 can transfer inside the triangle here because vertical angles are congruent. I'm also going to highlight this linear pair. Sometimes we don't notice the linear pair, but there's a linear pair sitting here on the right, and linear pairs are supplementary. So 180, take away 152, is going to leave me the acute angle of that linear pair, 28. So now I've got the 3 angles in the triangle now. I'm going to switch pen colors here. This is kind of the prerequisite work. You got to do your vertical angles. You got to do your linear pairs just to get enough information to work inside the triangle. Now that I'm in the triangle, I'm going to use the triangle sum theorem that says the 3 angles have to add up to 180 degrees. So angle number 1, 98 plus x, plus angle number 2, 62, plus angle number 3, 28, has to add up to a total of 180 degrees. All right, let's combine like terms. 98, 62, and 28 combine for a total of 188. So I've got x plus 188 equals 180 degrees. And I have one final step to solve for x. Remove this positive 188 by subtracting it. And I'm going to get x equals -8. X equals -8. Now let's check it. If x were to equal -8, 98 plus -8 is 90 degrees. So does 90 plus 62 plus 28 make 180 degrees? 90 plus 62 plus 28 does make 180 degrees. Okay, so to sum up these 5 examples, hopefully this gave you a really good look at what's going on within the angles of the triangle. It does not matter the size or shape of the triangle. We've got obtuse angles, we've got acute angles, we've got right triangles. All the 3 angle measures will always sum up to 180 degrees. Our last topic to cover here is called the triangle exterior angle theorem. Okay, exterior, remember, exterior means outside. So we're talking about an angle outside of the triangle exterior angle theorem. So here in my examples down below, you'll see the question mark often sits in the exterior angle, or maybe a value of x we'll be looking for, the exterior angle. So this is kind of a shortcut theorem. It makes some work go a little bit faster. The triangle exterior angle theorem says that the sum of the 2 remote interior angles sums to the exterior angle. Let's write that down. The sum of 2 remote interior angles is equal to the exterior angle. All right, jot that down a second and then let's talk about it. The sum of 2 remote interior angles is equal to the exterior angle. Now, when I say remote interior, that's a funky word, not like the remote control, but remote means far away, not connected to. We could also say non-adjacent. So the sum of 2 remote interior angles is equal to the exterior angle. So in example 6 here, we have the exterior angle where the question mark is. I'm going to put an E right here for exterior. The remote interior angles are the angles that are not the linear pair. So right now my pen is sitting in the linear pair. It is an interior angle, but it's not remote. It's not far away from the exterior. So I'm talking about angle S and angle R as the interior angles. These are the remote interior angles. So this theorem says that the sum of the 2 interior angles equals the exterior angle. So let's do that. 45 and 65, that sum is 110. So that means our final angle measure here is 110. Now I'm going to take a minute and walk you through why that works, okay? You don't have to write any of this down unless you want to. This works, if we were to work this the long way, if we were to use the triangle sum theorem to find this missing angle, I'm going to put an X here, we would have to do 180 degrees minus 45 and minus 65, which would leave me with 70 degrees. So this angle would be 70 degrees using the triangle sum theorem. Then I'd have to switch over and use a linear pair. Now we know linear pairs are supplementary to each other. So, excuse my phone. Linear pairs are supplementary to each other, so we would have to figure out 70 degrees, 180 degrees, take away 70 degrees, and that's 110 degrees. So it took us 2 steps to do this work without the triangle exterior angle theorem. It only takes us 1 step if we use the triangle exterior angle theorem. So it's much faster. Let's use the triangle exterior angle theorem on example 7. Here's our exterior angle down at point Q. Remote interiors would be at angle S. I'm going to put an I for interior, and angle R. This theorem says that the sum of 2 remote interior angles is equal to the exterior angle, which means to add 20 plus 60 That makes 80. So our angle measure here on the exterior is 80. If you would rather work that using triangle sum and linear pair, that would be fine. But I think this is a pretty fast, easy option. In fact, it's the only option when algebra is introduced. All right, so let's take a look. Here we've got two algebraic expressions, one angle value. We're trying to solve for x. Triangle exterior angle theorem says the exterior angle is equal to the sum of the two remote interior angles. So the exterior angle is equal to the sum of the interiors. So let's write that out. 39 plus 3x plus 14, that's the sum of interiors, is equal to the exterior 20 plus 6x. I've been so impressed about how much work you guys have done on your equation solving throughout the year. So let's see what happens here. I'm going to make this my x side and this my number side. So I'm going to leave 39 here. I'm going to move 3x over. I'm going to leave 14 on the left. I need to move 20. Bring it on over here. And then I'm leaving 6x on the right. So on the left, I have 39 plus 14, take away 20. 39 plus 14, take away 20. I get 33 on the left. And on the right, I have positive 6x, take away 3x. Final step is to divide. 33 divided by 3 is 11. High-level algebra there, high-level equation solving skills, but it all comes from the setup. The two interior angles sum to the exterior. One more to try. Here we go. 130 degrees is the exterior. These two pieces on the right at angle R and angle Q are the interior. So my setup is going to look like this. Interior plus interior equals exterior. So 1 plus 14x plus 8x take away 3 is equal to 130. I'm going to make the left side my x side and the right side for numbers. So I need to move over the 1. I can leave 14x, I can leave 8x, I need to move over the 3. 130 take away 1 plus 3 is 132. On the left, all I have to do is combine 14x and 8x. 14x plus 8x is 22x. And then finally, I just divide. 132 divided by 22. And I get x equals 6. Okay, that was a lot of review. We've done a lot of good work here. These are all topics that you've covered at other times in your math career, and we're just summing it up here on one page. We've got 6 new vocab words that we have reviewed. We also have the triangle sum theorem as well as the triangle exterior angle theorem. Happy studying!